Professor Joshi. He has done his Masters in ENTC from College of Engineering Pune in 1976 and at present doing PhD in image processing on embedded platform. During his stint with industry, he has worked with various companies including AppLab, Melco and Microelectronics. His academic stint includes engineering colleges like MIT, Cummins, PVG, etc. He is actively participated in Board of Studies of Electronics and Telecommunication and worked as subject coordinator and involved in setting syllabus for various subjects including electronic circuit design, electronic system, advanced microprocessor, embedded system, etc. He has been instrumental in conducting various technical workshops under Pune University. He is also actively engaged with the industry and is actively trying to bridge the gap between the industry and academic through his various initiatives. I would like to have our CEO, Joshi, to felicitate Professor Joshi by presenting him a bouquet. Over to you, sir, please.
Thank you, Collector. Very good morning to all of you, and welcome to this workshop called Embedopedia. We have got today experts from industries. First one is Mr. Kalpak Dabir, Entrepreneur Embedded System. We have got Mr. Uday Vasule, Minda Industries. Mr. Abhay Buranpurkar from the Symphony, the organizer of this workshop, the invited academicians, other dignitaries, and my student friend. So it is a great day today that we have got such an opportunity to have an interaction with expertise. Now I will say it's a great combination that we have got all three here, that students, faculty representing myself, and industry expert. Normally we don't get such a combination mix. I have addressed many such workshops, but that too, for example, recently we have got syllabus detailing of embedded system. One workshop at Dhole Patil, Raisoni College, then we have got Bhujbal College at Nashik. But I addressed the faculties, how to how to work out the syllabus, what are the details to be covered, how to implement practicals. But I have never such combination of the things that we have today. So first I will talking about the three issues. The first one is what is the need of including the syllabus of embedded system in our curricula. That is the first thing. Second thing will be what initiatives we have taken to frame the syllabus, what is the need of this, and the third one will be what are the expectations from the industry. So the first one is why this syllabus included in our syllabus is included in our course. Now you can see that this world is full of embedded. You can say that every walk of life there is an embedded system. Like for example, we are sitting here, we have got at least 5-6 gadgets which are controlling all of the various devices like light, microphone, LCD projector. So we are with embedded system, embedded gadgets. You have got at your home there are 10-15 gadgets around you. When you travel, if you have got lucky enough that car like BMW, I think you must be aware that there are 100+ controllers which are monitoring and controlling that BMW car. But if you are not fortunate enough, you have got even two-wheeler, like latest two-wheeler had less 2 to 4 controllers. They are there, say like monitoring the fuel injection, for fuel efficiency, controlling, monitoring the speed and anti-black clock systems and all this. So every moment of time around there are embedded systems. So we cannot run away from this. So this is a basic theme. I would say that we being electronic engineer, and it's so close to us, the embedded system belong to us. We can say that it's basically hardware oriented, and of course there is a software. So I would like to just mention, like these are the devices. Now many of us, you know that these are the home segment devices, like your mobile phone, MP repair, video games, DVD players, GPS, all those. Many of us are using it, but very few of us know that these are embedded gadgets. Now what is the definition of embedded system? It's a small device which is smart, programmable, and doing a specific function, specific task with but which is not visible outside. It is hidden or embedded, and it is a part of a big system. That this system may be mechanical, electrical, electromechanical and others. So it is not visible, but if you see the characteristics of that, you will find that it's doing a specific job, it's a small size, it's a cost effective, and it's doing a very high performance. So, and working with a very low power. So from this we can make out that what is the embedded devices or what is the embedded system. Now there are many segments which are there in the domain. Like we have got domains, like one is automotive electronics, second one is consumer electronics, we have got industrial automation, we have got medical devices, mobile phones, military and aerospace, office and business automation, telecom and data communication, we have got wired and wireless communication. So these are the some few sectors that where there is a tremendous scope, tremendous potential for the growth of your career in this embedded system. Now we have got, we have to see that the situation, what is the current situation. Like we have got a potential growth and potential business in this embedded, like the NASSCOM, which says that report. I am not really true to this figure, but we have got industry expert, they will probably tell us what are the figures, but I just say that something 10 to 20 billion dollar business is happening in this, and there is a growth rate of 15 to 20% happening in this area. Now we require, typically we have got some 60,000 to 1 lakh engineers in the currently working in our Indian industry, but as per the NASSCOM report, they say that there is a requirement of 6 lakh engineers till 2015. So we can see that just less of 1 lakh, and we have to reach to 6 lakhs. In just now we have got 4 years left. So and such a business, and the business predicted is something $25 billion. And if you compare this business with this all over world, it has already crossed $100 billion. And there is a separate potential outside also. Many of us, you go outside for higher education and you get a jobs also, very good job. And this is the field where you will find that there are jobs. There is no recession, not at all. Maybe that we have got recession in your core IT industry, but there was never recession in embedded. And that is why many IT joints like in India, like Infosys, Wipro, then we have got TCS, then KPIT Cummins, and even Persistent. They started their separate embedded division. And probably this is what we also feel that we should have some subject so that students will be trained, will be expertise will be available for such industries in India. Outside, of course, they are already there. There is a tremendous potential for embedded engineers. But if you in India itself, we have got tremendous potential for this embedded system. So we have got this giants, Indian giant, but we have got many other multinational. For example, we have got something like Samsung is there. We have got LG. We have got General Electric, Philips, John Deere, and Delphi like this. So these are multinationals. So they have also started their business in India. Okay. And there is a tremendous potential. We can conclude that we have got a very high growth rate, very high potential jobs, and basically we will find that there was a recession few years back. Now, just few years back, or there was a recession, and this is a cycle repeat that every 5 years there are ups and downs in core IT. And many of us, you must be knowing that when the training placement happens, like I just recently we have got a news that at CUAP, Cognizant recruited 340 some odd engineers. Now, and so when I was talking to my student, I said it's good that you are not recruited to Cognizant, to the electronics student, because they are going in a core IT, and we have got some 39 subjects in 4-year course. I said that you are just going to forget all, and you have to start somewhere working on .NET, Java, some other platform, and that too you are going to work for just 6 months training, and you are going to start doing the work. And what is the use of the 39 subjects you have learned for 4 years? So that is and that industry is also very is uncertain. So therefore I feel this is the core industry whereby your knowledge will be directly used, will be useful, and there will be a satisfaction also. Like say I have learned this subject and I am using this, I am working on this. But something like you go to the core IT and then you start learning which you never liked. Like somebody, see, this is my experience, that if I ask to write a program in C language, you are not comfortable. You want to write in assembly language, you are comfortable. You don't want to beyond C. Forget about C++, Java or .NET frameworks which are in the higher abstraction level. You never liked, I know that this is situation. But when you enter in the industry, you have to. So you have to compromise your personal desires. So considering all this, I feel there must be a subject, and this we started. It's not that today we are here, workshop is today, but in 2006 when the giant companies in India started a separate division, embedded division, we introduced this first course in 2006. And I am proud to say that this is the only university, that is Pune University, who has introduced this subject at UG level, at undergraduate level. See, all other like IITs, Regional College of Engineering, they have got this subject at the postgraduate level. Ours is the first university. In 2006, we have got such subject at undergraduate level. And basically, we know that this tremendous potential, like jobs we have mentioned 6 lakhs, say maybe that we have got say 2 lakhs, the prediction is always high, but still we can say that a lot of engineers are required. And if you consider postgraduate level, I think they are highly specialized and their numbers are very, very few. So I think that will not meet the demand, that what is required. So this is how the situation, that why we have got subject introduced in the University of the Pune. So now, what are the initiatives taken by the Pune University? Now Pune University, we have introduced 2006, but the basic foundation is done 2 years back. See, we have introduced subjects called microcontroller and applications, now with practicals. Now the story, this is a course we introduced in 2003. See, we have got syllabus revisions happening previously 7 years, 6 years, and now we have got a revision of every 5 years. So we introduced the microcontroller application. Now this is in 2003. Now in 1997 we had this subject, but there were no practicals. There were no hardware practicals, I mean to say. There was only a software, right, simulator, and passing or the examination, it was term work. So you know that when there is a term work, what you do? So you just copy the assignments, and that file is ready, and we also sign it without looking into that much, because it's a term work. So you have no practical idea, no practical idea of interview. So this is the first subject we introduced with the practicals, and that to see we have got, see, this is very important. In the old course we have got something not development kits, say famous from Dynalog and all those things, and Schumann, all this, and those kits we are running. We are running program in the RAM, and whenever we ask question that where your program starts, students say that location 4000 hex or 6000 h. But we already know that when you reset your controller, it starts from mostly 00 location. So what to do? So when this is a problem when you do actually practical projects. When you want to make your own project, you have got no other support like monitor program from the development kit. Then what to do? So we started, okay, nothing doing that running program now, let us have a flash. Program in a flash and do your routine start from 00, scratch. And do your own subroutine, like you want to have basically LCD display, keyboard, this is the basic. Then we have got all other peripherals. So we introduced this, all the peripherals like ADC, DAC. Then we introduced SPI based, I2C based peripheral, because this is very important. Now the days are gone that we have got external big chip of some 24 pin chip of ADCs. Now all the pins are reduced to 8 pin number, and we have got all I2C communication or SPI communication. So we introduce all this in our syllabus. That's something great, I feel. And one very interesting situation, when the syllabus was about to change over, like we have got batch at the BE with the old course and batch at the T, the new course. And literally we found that the third year student helping final year student for their project work. That's something great I observed. So that's a great success, I feel. That third year student helping for their, like my LCD routine is not working. So third year student, let me solve your problem. And this is something improvement I feel. So this is the basic foundation. So we introduced 8-bit controllers like basic 51. Then recently we introduced PIC and EVR, because we know that 8051 is also not useful to industry. It doesn't contain peripherals which are required built in. Now the PIC AVR has got almost all the peripherals. They have got ADCs, EEPROM, the flash, all now advanced one have got built in I2C, then RTCs and whatnot. So all the support. So we introduce high-end controllers like PIC controllers, EVR controllers, and remember the old course there was no practical on the PIC or EVR, but this course, that is 2008 course, we have kept 2 practicals on PIC or EVR. So we are getting real flavor of that how to use, and this is very useful because if you want to do mini projects or final year projects, most of the projects involve some microcontroller. You cannot have a project without microcontroller. You may have got some other systems like power electronics or other things, but the basic controlling element is a controller. So either 8-bit, okay, 16. Now the next step was to introduce an embedded system which requires a high-end processor, like we require a 32-bit processor or controller, because if you want to have an operating system like RTOS, now RTOS requires a lot of space, lot of memory, then require protections and all those. So these 8-bit controllers are not sufficient to have a real operating. We can have some experimental RTOS, small RTOS, possible that 4 tasks and all that. So we introduced the next course, advanced microprocessor, 32-bit processors or controllers, like ARM processor is one such most popular. We have got 386 or 32-bit, but controller side we have got ARM based controllers, and we introduced a very popular LPC2148 chip, and we have got practicals also, again interfacing with peripherals with these 32-bit processors we introduced. And then the final year, that is 2006, we introduced embedded system, whereby we have got then concept of RTOS. What is the comparison between general OS and embedded OS? What is the difference between real-time OS, and how to have the functions system calls implemented? What is the multitasking, and how it is useful if you have RTOS, how it is difficult without RTOS, all this concept with experiment we have. And this is what in 2003 syllabus, that is something 2006-7. And we have got workshops, specifically we have got support from Embedded Oasis technology. So they help us like anything. They arrange 3 days workshop, and we even faculty were not aware of how the RTOS works. Let us be frank. See, I am passed out of 76 UAP, and we have got just transistor circuit. See, I have built a multi-vibrator, some 4 flip-flop using some 16 transistors that time. That was my experiment at a BE level. But then over a period we must adapt, we must change ourselves, we must adjust to the technology what is happening. So that is what is needed. So we also learn the RTOS and we learn ARM like you. So nothing wrong in that, nothing this thing. So this embedded system introduced 2006. We have got Mucos 2, which is again free, simple operating system. But then we realized that high-end applications cannot be done with the Mucos. And this year, this is the first batch. I think many of you must be having that elective. We have introduced Linux, embedded Linux as operating system 1 unit. And where we know that it's the first of all free. Now it is modular. You can attach module to this, and there is a lot of device level support available, and it can work in a protective mode. Okay, so therefore, to support this, we have got ARM7, which doesn't, that is LPC2148 is one of the example at ARM7 core, which doesn't support memory management unit. Okay, so therefore we cannot have protection. So in high-end applications, we require protection with each other, with the memory, processor, kernel, and operating. So we introduce ARM9 okay, something now Atmel 9260 or something or 9260.123. So which has got built-in memory management. So we are going to work on this embedded platform. So there is a need to shift from PC-based application to the embedded. So this requires a lot of help from industry. Now the solutions to this talent crunch. See, there is a crunch of talents. That is what says 7 lakh engineers are required. We have got just 1 lakh. So there is a crunch of talents. So this lies in the, so how to sort out this talent crunch? What is the solution? So the solution will be like only the industry academia collaborations. If you have got conferences, meets, workshops like this. So company types, so what are those? So company tie up with universities or setting up industries to equip engineering graduates with the requirements. So we require some sort of tie-ups. Something like setting up technology business incubators. So the incubator is there, something. Or something we call finishing schools. So after your graduation, you have got some finishing school, so you have what is the industry actually requires and how to be prepared for that. Now in case of see this field of medical science, we know that when the a person is graduate of medical science, he has to do internship of 6 months in a hospitals. And apart from that, during their normal course also, they are fully busy with real life, like they are have daily visits with your hospitals and they receive the real, but that is not a situation for us. See, they work very hard. I always give example of medical graduate. They work like hard. They don't just think of the time of the day. They work in the night in the hospital. They have got night duties. But in our case, you think yourself. You come to the college around 10:30 and you will leave before 5 o'clock. And you don't want to wait anymore in the colleges for doing extra. Now you compare with this. See, this is also a professional course. That is also a professional course. See, to get expertise, knowledge gain, for professional you require a lot of papers. Just passing in subject, I feel is not sufficient. And that's why there is a complaint from industry that only 20% of the graduates are really employable. And that is really true also. Because we just study for marks of 40 in our papers. So 40 mark is not at all sufficient. And that too is just you just study for last few weeks before your exams. And then you try to reproduce whatever it. And after exam also again you forget that. So when your interview starts, you are almost blank and you miss the basics. What industry wants is not only expertise but the basics also. If your basics are clear, you can develop your expertise, provided you are sincere enough. So my point here is that we should have something from industry like this, something called incubators or finishing schools. Performance-based incentives should be provided to faculty. Now this is very interesting point that faculties also are reluctant to study. A person like me, now almost I am completing my career, but still I am now pursuing my PhD on embedded platform for image processing. So I have got still zeal to study something more. I want to interact with what is happening. So that is why I am in this syllabus making business. They are appointed because they know that who are the persons who are really bothered about this, the syllabus, what are the situations required in industry, and how to make this situation favorable for our engineers. Because see, the jobs basically are for the IT engineers. Now there are 340 students in the cognizance and like many more. But where are the jobs for core sector? Like you are in electronics. I find that many colleges, the jobs are 5 to 10%. Total placements are 100, say. Only 5 to 10 engineers are employed in a core industry. And remaining 90% in IT industry. And that situation has to be changed. That situation must be changed. And for that, we should have some, this is one of this area, this embedded system, and then VLSI, ESP. These are the core areas, say hot cakes. And out of that, so embedded is, see, embedded includes DSP and VLSI also. See, embedded includes everything, analog, digital, VLSI, all. So if you are good enough in embedded system, I think we can change the situation, like the core sector employment can grow to some 30% or so. That will be good enough. So involvement of industry, see, faculty I was talking, that faculties are elected. So we want some incentives from the industry. And there must be some for scholars, like research projects. Because see, recently I am working at PVJ College of Engineering. See, we have got NBA committee for inspection, accreditation. And they said that how many research projects your students are doing? How many faculties are in consultancy to industry? And the situation was very, very poor. It is still poor in all colleges. All colleges we have. So this situation has to be improved. So there must be some incentives. I don't know in what form, but it should be there. Involvement of industry executives. Now we have got some 3-4 executives here in academics and creating awareness about the job awareness. So this is what I think today's aim. So create the awareness and job awareness. What is the scope and what are the jobs available? And this is what the focus of today. Participation of industry beyond just providing tools. Like some industry may expect like some tools, some laboratory development, labs are set up by you people. By you people means industry people. So that, see, many colleges I have seen, I am around 20 years in this academics, and I know each and every college, I know each and every staff member of all colleges, and what is the lab setup, which equipments are there and which equipments are not there, working over 20 years. So I found that many colleges, they don't have minimum setups required for our conduction of experiment. See, last year I was examiner, I found that there is no PIC kit, controller kit, which cost some 6,000-7,000 rupees each. So the college could not purchase 14,000 rupees to purchase 2 kits of PIC controller, and because of that, students could not perform the practical on their PIC kit. And that's why they lost this knowledge or opportunity they should have, what we have decided. So if industry can help us to provide this laboratories setup, or you can have some facility at their industry, it's difficult, I know that, so that students or faculty can make use of it. National level conference every year. I think this is a concept in the foreign developed countries. They have got every year or every 6 months a big conference at national level. So this is not happening in our country. That this, I think we should have something at national level involving faculty and industry experts. Both should be involved. University should adopt changes according to the syllabus, what is happening in this situation in those conferences. Training to faculty in new technology is expected. Like Oasis has arranged 3 days workshop, 2 days workshop. Similar such seminar workshop, if you can arrange that, industry people, it will be very good. Briefing, and in that they have to brief that what are the expected. So this is a very important point from student point of view, that what is expected from the students as per current scenario, like what this is the situation, what do we expect from students, and that will be a benefit to the students. So before I conclude, I would like to thank all these experts from various industries, and specifically the Oasis Education, Oasis Technologies, who have supported in framing the syllabus, in implementing the syllabus. They have arranged 3 days workshop in 2007, then 2 days workshop recently in this August at Ullas Dole Patel College of Engineering. They have helped us in organizing the workshop at Bhujbal Knowledge City, at Raisoni College, and whenever we call, that whenever we have our doubts, queries, we just call, give a call, and they come within hours time. So I must appreciate the help given, and they will continue to help. Similar level of help.
Thank you very much.